If you're the leader of a small, isolated nation, you face a terrifying reality. You are surrounded by heavily armed adversaries. Your conventional military is completely outmatched, and you believe your only true survival insurance policy is a nuclear weapon. But you have one massive problem. The moment the international community catches you building one, your economy will be dismantled by sanctions, your regime will face total isolation, or a fleet of stealth bombers will appear over your airspace to obliterate your facility before the bomb is even finished. So, you choose the only logical option left: absolute, total secrecy. You bury your laboratories hundreds of feet beneath solid granite. You launch elaborate front companies to buy equipment. You completely air-gap your computers from the internet. You tell absolutely no one. You think you've built a ghost program. But thousands of miles away, inside windowless operations rooms in Vienna, Washington, and Tokyo, intelligence analysts aren't guessing about your plans. They're watching your progress in real time. They know exactly when you turned on your machines. They know how many you're running. And they know down to the single week when your first warhead will be ready. Because in the 21st century, hiding a nuclear program isn't just incredibly difficult, it is physically impossible. To build an atomic bomb, you need a very specific type of fuel, either highly enriched uranium-235 or plutonium-239. And this is where nature plays a cruel trick on you. When you dig raw uranium ore out of the earth, 99.3% of it is uranium-238. This is a heavy, stable isotope that is completely useless for a nuclear explosion. Only a tiny fragment, just 0.7%, is the volatile fissionable isotope you actually need, uranium-235. To separate the two, you have to turn solid rock into a highly corrosive radioactive gas called uranium hexafluoride, UF6. Then you pump that gas into a machine called a gas centrifuge. But here's the catch. A single centrifuge only enriches the gas by a fraction of a percent. To get enough weapon-grade material for just one single bomb, you need thousands of these hyper-precise machines lined up in a massive interconnected maze called a cascade. And this is your very first insurmountable problem. You cannot build a modern centrifuge cascade out of parts you buy at a hardware store. They require ultra-exotic materials that are heavily tracked across the entire planet. The second your front companies try to buy these specific materials on the global gray market, silent alarms go off. The International Atomic Energy Agency tracks the global supply chain of dual-use materials with obsessive precision. If a random textile factory or bicycle manufacturer in Asia suddenly places an order for tens of thousands of high-tensile carbon fiber, a red flag is raised instantly. To keep thousands of centrifuges spinning at hyperspeeds 24 hours a day, your hidden factory requires a massive, unyielding supply of electricity. It's not just the motors. Spinning thousands of mechanical tubes generates an incredible amount of friction and heat. Left unchecked, the entire cascade will overheat and destroy itself. That means you need industrial-scale cooling systems running around the clock. If you plug your secret base directly into your country's national power grid, satellite analysts will instantly notice the sudden, unexplained surge in energy distribution going to a remote area. Thermal infrared satellites are specifically tuned to see heat. Even if your facility is buried 300 feet under solid rock, that intense heat from the centrifuge cascade has to go somewhere. It vents through hidden exhaust shafts, or it slowly warms the rock and soil directly above the bunker. To a thermal satellite looking down at night, your secret base glows like a neon sign in a pitch-black desert. Computer simulations and physics equations can only get you so far. Before you can confidently mount a nuclear warhead onto the tip of a ballistic missile, your military will demand proof that the physics design functions perfectly. You have to detonate it. Since testing a bomb in the atmosphere or underwater is an immediate catastrophic giveaway, you're forced to go underground. You drill a deep vertical shaft inside a remote mountain range, drop the device down the hole, pack it with concrete, and flip the switch. You think the solid crust of the Earth will muffle the shockwave and keep your secret safe. It won't. The Earth is an incredibly efficient conductor of seismic energy. when a natural earthquake happens, is caused by tectonic plates grinding against each other. This friction creates a complex, messy mix of lateral shear waves, known as S waves. But a nuclear explosion is a single, violent point source. It doesn't grind. It violently punches outward in all directions simultaneously, compressing the surrounding rocket in an instant. To confirm their suspicions, scientists look at the depth of the event. Most natural earthquakes happen several kilometers deep within the Earth. Human engineering, however, can generally drill only a couple of kilometers down. If a magnitude 4.5 seismic event registers at a depth of exactly 500 meters beneath a mountain peak, in a zone with zero history of tectonic activity, it's not an earthquake, it's a weapon. A nuclear weapons program cannot be built by a lone genius in a basement. It requires a massive industrial ecosystem composed of thousands of elite minds, theoretical physicists, chemical engineers, advanced metallurgists, specialized software developers, and high-level logistics officers. They read highly specific, incredibly obscure academic journals. They attend very particular international symposia. And most importantly, their daily habits change uniformly. Intelligence agencies use advanced data analytics to monitor these subtle human anomalies. If dozens of top-tier nuclear scientists within a specific country suddenly stop publishing research papers, delete their social media footprints, and relocate their families to the same remote territory, the world notices. And once that target is drawn, you face the modern world's most devastating weapon, cyber warfare. In 2010, the world discovered Stuxnet, a highly classified cyber weapon developed by Western intelligence. It was engineered to target Iran's enrichment facility. Stuxnet hijacked those controllers. It forced the secret centrifuges to spin dangerously fast, then dangerously slow, physically tearing the rotors apart from the inside out. All the while, the virus altered the data being fed back to the control room monitors, showing the operators a fake stream of numbers that said everything was running perfectly. By the time they realized what was happening, a fifth of their entire centrifuge network had been physically reduced to scrap metal. The international political system is inherently messy. Geopolitics can stall treaties, intelligence agencies can misinterpret data, and international bodies can be frustratingly slow to react to emerging national security threats. But the physical net designed to see through nuclear secrecy is absolutely flawless, because it doesn't rely on politics. It relies on the immutable laws of nature. To build an atomic weapon, you are forcing the universe to do something it fundamentally does not want to do. And the exact moment you force the hand of physics, the universe leaves a trail that the entire world can see. Thank you for watching. If you enjoyed this video, don't forget to hit the like button and subscribe.